Welcome to the Living with OOOOb webinar hosted by EcoVapor, a DNOW company and part of DNOW's Process Solutions Group. Our high caliber panel of experts is here today to share their expertise. Thank you, gentlemen, for being here. Today we have Hans Mueller, Vice President with EcoVapor. Say hi, Hans. We have Marcus Knox, R&G Product Manager with EcoVapor. Chris Colclaser, attorney and shareholder with BD Wozniak, and Chad Powell, Senior Project Manager for Air Quality at Quandary Consultants. Thank you, everyone, for being here. Hans, I'm going to hand off to you.
Thanks, James. Hi, everyone. I'm Hans. Thanks for being here today. To get started, I think that it makes sense to talk about the current state. You know, what's the same, what's changing, what might change, where the current environment is and where that might be going. So I think first off, let's address the elephant in the room, implications from the election in November. Republican leadership will likely prioritize energy independence by encouraging domestic oil and gas production. Oftentimes that's done through relaxed regulations and expediting permitting processes. We've seen that before. I think it's fair to say that that's a fair expectation going forward. This likely will increase U.S. oil and gas exports, such as LNG. I'll talk about that in a sec. But it also may lead to reduced focus on emissions in the sector. So where does that leave us with regulations? Well, right now, I think the accurate way to say it is that the Supreme Court has recently affirmed that the EPA can enforce the methane rule, which includes the waste emissions charge, while legal challenges do proceed in lower courts. Changing or repealing that waste emissions charge does require an act of Congress because it was created through an act of Congress. It was created through the 2022, as part of the 2022 Inflation Reduction Act. However, incoming Trump administration can influence the EPA's implementation and interpretation of the waste emission charge through rulemaking. And as we mentioned earlier, judicial review is ongoing in the lower courts to assess whether the EPA exceeded its statutory authority. So stay tuned. I think also gas prices, they were high a couple of years ago. They've been low, but in 2024, they have been on the climb, about 30 to 50% globally, at least in Europe, Asia, and North America. And that climb is set to intensify this winter due to high demand and tighter supply, limited production increases, and also I think that something that might most affect the North American market is that the existing LNG export ban was put in place by executive action under the Biden administration, which means that it can be canceled day one through executive action by the incoming administration as well. Another thing to be aware though is that state plans that are created under the emission guidelines for methane reduction, Quad OC, they can be more restrictive than federal requirements, even during a presidency that does prioritize deregulation. So federal standards such as Quad OB, all the other O's, they set the baseline for the nation, but the Clean Air Act explicitly does allow states to exceed the federal environmental standards. We've seen it where states with progressive environmental policies can use this discretion to set more aggressive emissions reduction targets. And that is something that the courts have upheld in various challenges to state-led environmental initiatives. So that's just setting the table. We'll go deeper into the regulatory environment here shortly. But today, I think we start out with that regulatory overview. Chris Colclaser with BD and Wozniak is going to be presenting that. And we'll go into compliance and really implementation of that. That's going to be Chad Powell with Quandary Consultants leading us there. And then at the end, talk about some targeted solutions to address aspects of the Quado and its various forms. That's something that Marcus and I will lead. But ultimately today, folks, the purpose is education. Let's go over the lay of the land, where it's moving, and at the end we'll try to arm operators and regulators with an understanding of some of the tools that have evolved and how they work. So I'll pass along to Chris for a deeper dive into the regulatory side.
Yes, good morning, and thank you, Hans. It's a pleasure to be here today. So I'll start with some big picture issues and then highlight some of the specific components of Quad O, B, and C. First, the two rules generally cover the same equipment. The difference is timing, the jurisdiction, and then the pollutant that they apply to. So for timing, Quad OOOb applies to sources that are new, modified, or reconstructed after December of 2022. And Quad OOOc covers sources that are existing as of that date. And they can flip to Quad OOOb if you modify these sources later. For jurisdiction, Quad OOOb is an EPA rule. It has been federally enforceable since May 7th of 2024. States can enforce Quad OOOb if they adopt it, or if EPA delegates the program authority to the state to act in their place. Quad OOOc is an emissions guideline, that's the EG on these slides, with a model rule. And states have 2 years to promulgate their own state rules that will set compliance deadlines of May 2029 or earlier for each of the affected facilities. In terms of the pollutant, Quad OOOb applies to both VOCs for volatile organic compounds and methane, but Quad OOOc is only applicable to methane because of how the Clean Air Act is written. Your control devices or vapor recovery units would reduce both, but you have to calculate emission rates differently for VOC and methane based on the composition in your gases. Along with the new emission limits, EPA revised the subpart WGHG reporting rules. They have much higher methane slip emission factors and crankcase ventilation from engines. And last month, EPA published the methane tax rule, or the waste emissions charge, which charges a fee per ton of methane emitted above a certain threshold. And for production facilities, that threshold is 0.2% of the natural gas produced, or 10 metric tons of methane for every 10 million barrels of oil. There is, like Hans mentioned, wide speculation that this will be overturned by the Congressional Review Act, but the charges are set on statute or in statute, and unless Congress also changes the Clean Air Act, which can be filibustered, you would have some uncertainty where the charges are mandatory, but EPA can't collect them. This timeline shows the applicability dates for the Quad O rules. There are 2 key points here. First is that Quad OC sources can still be covered by the original Quad O or Quad OA. So a well pad built in 2020 is subject to Quad OA, and it's new for that rule, but it's also existing under Quad OC. And second, your status can change. If you modify an existing source, it can become subject to Quad OB. For example, if you refrac a well, that modifies the fugitive emission components at the production pad and changes the LDAR schedule for that pad. So next, I'm going to go through some of the particular aspects of this rule that affect some of the facilities where vapor recovery units that Marcus and Chad are talking about might be helpful to you. I'll start with well completions. So a well completion, this is the step after drilling a well to prepare it to produce oil and gas. And this includes fracking and flowback. Quad OB puts these wells into 2 groups. Subcategory 1 has all wells except wildcat, delineation, and low pressure wells. These wells have higher requirements because they're closer to infrastructure. Subcategory 2 is for the wildcat, delineation, and low pressure wells, and these have less stringent standards. For subcategory 1, you have to have a separator on site for the entire flowback period if you're going to frack the well. And for initial flowback, which is the stage before it is technically feasible for a separator to function, you must route the liquids to a completion or storage vessel, but you don't have to control the initial flowback gas. Once the separator can function, then you enter the separation flowback stage, which lasts until production starts. During separation flowback, you route the liquids to a storage vessel, a collection system, such as a produced water gathering line, or you re-inject the liquids into a different well. You also have to route the gas from the separator to a flow line, meaning a sales line, or re-inject it or use the natural gas on site as fuel. For subcategory 2 wells, again, the wildcat delineation low pressure wells, you can route the liquids to a completion combustion device, or you can route them to a completion vessel with a separator and take the gas from that separator and send that gas to a completion combustion device. So turning to associated gas wells, these are wells that produce oil or condensate along with natural gas. Historically, if there were no gas gathering lines or infrastructure in place, operators would sometimes vent or flare the gas. There have been some state rules to restrict this, as well as BLM has its waste minimization rule that it finalized at late 2023. But EPA is sort of getting into the game here with its Quad OB restrictions on associated gas wells. The rule generally prohibits venting and flaring of associated gas. And I would just point out that the flowback emissions I just talked about before you enter the production phase, that is defined as not associated gas. Likewise, if you are getting natural gas from a wildcat or delineation well, that is not associated gas. And so this rule does not apply. But under Quad OB for associated gas, you cannot vent or flare, with some exceptions for when flaring is allowed. If you demonstrate that it is technically infeasible to route that natural gas to a sales line or use it on site or re-inject it, you can control it to 95%. And I'm using this term flaring, but control it to 95%. You must make this demonstration and annually certify that it is not technically feasible to route the gas to sales or use it or re-inject. There's some dates here about a phase-in. A well that is drilled after 2024 can only use this exemption to flare through 2026, so only for 2 years. But the wells that are slightly older can continue to certify annually and control gas to 95%. There are also some temporary exceptions for flaring during malfunctions, maintenance. If you lose your gas takeaway capacity, you can temporarily flare, and in very limited circumstances, you are allowed to vent for just a few hours, very short periods of time. That's for new wells under Quad OB. For existing wells under Quad OC, the requirements are generally the same, but the threshold is different. So a well that is less than 40 tons per year of methane, an existing well, may flare or control the gas to 95%. If it's above 40 tons per year of methane, it may flare with the annual demonstration and certification of technical infeasibility. And this is going to be my last slide on storage vessel requirements. So storage vessels are subject to Quad OB if the potential emissions from the tank battery are 6 tons per year of VOCs or 20 tons per year of methane. And again, this is per battery, it's not per individual storage vessel. If the emissions drop, the uncontrolled actual emissions rate drops below 4 tons per year of VOCs and 14 tons per year of methane over a rolling 12-month average, you can remove the controls, but you may need to put the controls back in. If you refracture the well, you have to control emissions from the tanks immediately. And if your emissions from the tanks just rise, then you have 30 days once they exceed that level of 4 or 14 tons per year. The requirement is to control emissions by 95% from each tank battery. But I would point out that, again, your Quad OC tank battery can become subject to Quad OB if it changes. So if you make certain modifications, and that would be adding a tank, replacing a tank in a way that increases total capacity. If your throughput increases, if you add a new well, or if you frack a well, that is a modification and you'd be subject to Quad OB immediately. So your deadline would be accelerated. You'd have to comply with the federal rule and not wait for the state plan. And then finally, combustion controls or flares are subject to some pretty extensive requirements about legally and practically enforceable limits, monitoring, record keeping, performance testing to make sure that you're getting the 95% emissions control. If you use a process unit, which could include a vapor recovery unit, that is not subject to these lapel requirements. And turning it over to Chad.
Thanks, Chris. As you can see, here is a list of the equipment that is potentially subject to Quad OB. You should understand and know these pieces. Nothing has really changed from the previous Quad OA regulation. Some of the definitions have changed, but overall the equipment itself is pretty much the same. But on the next slide, we're going to discuss those differences between some of these regulations. When it comes to the differences between Quad OA and Quad OB, the centralized production facility definition was actually formalized under Quad OB. It wasn't necessarily in the definitions previously, but it was mentioned a few times throughout the rule. There's also wells. The wells changed previously. It was if you did a completion operation with fracking or refracturing, that it would pull you into Quad OB. Now it's just a matter of newly drilling a well. If you newly drilled a well, then you can be pulled into Quad OB. There's also the inclusion of regulations that Chris had just discussed about associated gas and those requirements when that well is newly drilled. For pneumatic controllers, they changed the definition a bit. Beforehand, pneumatic controllers were more specifically anything that had a usage rate, a gas usage rate of 6 cubic feet per hour or more. Now it's simply a process controller. And there are requirements associated with that that kind of change the game compared to how it was previously done. When it comes to storage tank batteries, there's some new criteria, and Chris briefly covered that as well. When it comes to emission thresholds, many of the thresholds were always at 6 tons per year for VOC emissions. Now there's a new threshold of 20 tons per year for methane. You have to look at both of those components to determine whether or not you exceed those limits. It's also now based on not just the number of tanks, it's based on the entire battery itself. Beforehand, I know a lot of operators divided the number of the amount of emissions by the number of tanks. That is no longer allowed. You have to look at the entire tank battery. It doesn't matter if it's 1 tank or 30 tanks. It's a 6-ton threshold for VOCs and a 20-ton threshold for methane. There's also a redefining of the modification and reconstruction applications for storage tank batteries. That's really changed things up quite a bit. There's a few different definitions to be aware of. When it comes to modifications, you have to meet the criteria as far as the emissions go for VOCs and methane. And then you also have to meet one more criteria. If you add a storage vessel to an existing tank battery, it would be considered a modification. If you replace one or more storage vessels such that the cumulative storage capacity of the existing tank battery increases, you have modified the battery and make it subject to Quad OB. If you have tank batteries at well sites or centralized production facilities, and the existing battery receives additional fluids, crude oil, condensate, produced water, anything along those lines, then you have modified the well. And then also, if you have tank batteries that are not located at a well site or centralized production facility, including compressor stations or onshore natural gas processing plants, if you receive any additional fluids which exceed the throughput used in the most recent determination of the potential for VOC or methane emissions, you have thus modified the battery and would potentially be subject to Quad OB. Also, for reconstruction, you have to meet either that 6-ton per year threshold for VOCs or the 20-ton threshold for methane, and at least half of the storage vessels are replaced in the existing tank battery that consists of 1 or more vessels. That would trigger a reconstruction. And then another part potentially is that if the fixed capital cost of the new components exceeds 50% of the fixed capital cost of a comparable entirely new facility, you would trigger the reconstruction definitions. Those are all important points that you need to keep track of when it comes to making any changes on the facility. If you are pulling tanks, if you're adding new tanks, if you're replacing things, just keep that in mind. There's also a new component that's not necessarily equipment. It's known as the super emitter program. The super emitter events, it talks about some of the differences. And the interesting thing about this is there's a threshold over which, if you are above that threshold, you have to do a full investigation. The interesting thing about super emitter events is that EPA didn't just include it in Quad OB, they also included the language back in Quad OA and Quad O. So anything that meets the applicability dates and is determined to potentially be above that emissions threshold, the operator may have to do a full investigation. Now, that investigation cannot be initiated by anyone. It has to be by someone that is a qualified third-party reporter. There is a process that you have to go through that the EPA would approve that party. There is also a means for that party to be removed as a third-party reporter. As far as the EPA notification goes, once the EPA notifies the operator, they have 5 days to begin the investigation into the emissions. And that investigation has to be completed within 15 days of receiving that information. If there is no oil or natural gas facility within 50 meters of the coordinates that are provided by EPA, then the operator simply has to follow up with the EPA and let them know. At that point, there's no further action required. However, if you find that it is your facility and there were some potential for leaks that were in exceedance of the threshold, then that operator would have to begin that investigation. And there's a number of items that have to be reported. There's a lot of details. You have to go through maintenance records and see if there were any malfunctions or anything that could cause that event. You have to do an OGI or Method 21 inspection to identify any leaks. If there are any leaks found, you need to be able to go in and repair that leak. And you have to use the guidelines provided in Quad OB when it comes to initial step to repair it, and then also when that repair is completed. All of that information gets wrapped up in a report that is then provided to the EPA. So keep that in mind when that, if that were to occur to you, you do have a timeline and you need to follow. Next up, we have EcoVapor, who will be talking about a few other elements.
Awesome. Thanks, Chad. Yeah, let's talk about a couple of ways to achieve that compliance. But before we do, I think we can call a thing, and that is that the rule is massive. I don't know if other folks have had a chance to crack the book open on Quad OB, but there's a lot in there. In fact, same is true with Quad O, Quad OA, now B and C. You know, individually they're extensive, but altogether there's just a lot in there to understand. And I think that it's good to take a look back and say, okay, what has changed, but what remains the same? And over the past 10 years, there has been a lot of change, but what has remained a constant is that the EPA wants to see a decrease in emissions, and I don't think that they're alone in that. But their target has been a 95% reduction in uncontrolled emissions. That stayed fairly constant. And they also want those reductions to be effective, reliable, and ultimately verifiable. But how do we get there? You know, the regulations themselves, they have evolved and continue to do so. You know, and as has already been mentioned, you know, the threshold potential to emit requirement of 6 tons per year for VOCs, that's been in there before. You know, 20 tons per year of methane. Chris and Chad already talked about this, but I think it's worth reiterating that potential to emit threshold now applies to the entire tank battery, not just the tank. So that's new. That's an evolution right there. And also, I don't know about anyone else, but some of these units, they're not ones I deal with every day on a practical matter. You know, kilograms per hour, tons per year. You know, operationally, I'm more used to to volume per unit time. So just tying those two things together, 20 tons per year of methane, that's equivalent to 1.7 cubic feet per minute, or 2.5 MCF per day. I don't know if everyone else's experiences are the same, but relatively that doesn't seem like a lot of volume to trigger that threshold. And then also to be classified as a super emitter of 100 kilograms per hour, as Chad said, that's 129 MCF per day. I'm sure I'm not the only one on this webinar that's seen operational upsets that have resulted in more than that. So the thresholds, they do tend to move in one direction, it seems like. But just like the regulations are evolving, you know, so should the tools in our toolbox. And just like tools that you know we use in the shed, same principle I think is true for the ones that we use in the oil field. And that's that the knowledge of how to apply a specific tool for a specific purpose is critical. You know, how that tool is used and applied makes all the difference. So I'll pass it over to Marcus to take a look at the status quo, and then we'll take a high-level look at some of the tools that EcoVapor has developed and how they can be applied to meet the requirements in Quad OB and C.
Morning, everybody. Thank you, Hans, for the handoff. Yeah, okay. So you could think about this as a Quad OB and C facility. We have oil tanks that are uncontrolled and how they release VOCs and methane to the atmosphere, as the tanks are atmospheric and they breathe throughout the day. You know, while modeling has been acceptable in the past, you know, as Chad kind of alluded to earlier, measurements have revealed that not only are there far more emissions associated with tank batteries as a whole than originally modeled, but also there are questions about the destruction efficiency that are emerging from flares in general. The spirit of the EPA regulation is to avoid waste via the 95% verification of captured, emission sources that can easily turn into pollutants when they're released in an uncontrolled manner like this picture shows. And to kind of illustrate the super emitter point, a little more, depending on the application, so, there's 4 oil tanks here. If you can imagine, those are 4 750-barrel oil tanks. This configuration is potentially a super emitter event.
So let's start talking about some of the tools. How do we look at that status quo a little bit differently? And we'll start out with the 0.2. Why would an operator think about this? It's simply to put the would-be emissions into the pipe and sell them, and not put them into the air as emissions. The purpose is to dramatically reduce the emissions footprint of a production facility, and to do so profitably by selling that gas. So how do we do that? Well, by removing the contamination that pipelines don't allow. We've done other webinars on this topic where we go into a lot more specifics. That's really not the purpose of today, but at a high level, oxygen corrodes the infrastructure, the gathering network. No one likes pipeline leaks. It's also very reactive, and it messes with downstream processes like amine treatment. So therefore, pipelines have strict quality specifications for gas to enter their gathering network. And just like other gases, oxygen seeks equilibrium. That's a function of partial pressure and Dalton's law of diffusion, but that means that it goes where it's not, especially in low pressure environments like tank batteries. So what is this? This is a self-contained, self-controlled skid that purifies oxygen out of the gas that's typically found in vapor that's recovered from tank batteries, allowing for its recovery and sale.
To try and help, kind of condense this a little bit, we've kind of compiled a kind of a short list of regulations that we think are applicable and can be served by this technology. I would tell you it's a guide, but I'll give you kind of a couple of uses. As Chad mentioned, associated gas prohibits flaring and venting for longer than 24 hours, and you must use that captured gas to either sell or for some beneficial use. And kind of how Hans had mentioned, to sell that gas, you need to remove the oxygen, because oxygen is a corrosion accelerant, a very dramatic corrosion accelerant in pipelines, and everybody wants pipelines to work correctly. For liquids unloading, if the technology does not result in venting, then you are primarily responsible for record keeping and reporting only. If there is a venting event, it would fall underneath Quad O, and you would need to implement work practice standards. For storage vessels, this is kind of where we're most commonly installed, kind of like how I alluded to in the last slide on the uncontrolled tanks. It's applicable to tank batteries with greater than 6 tons per year of VOCs and or 20 tons per year of methane. Kind of similar to what was mentioned earlier, but you must demonstrate continuous compliance with the 95% capture. Luckily, for us, the 0.2 is a catalytic system that has no moving parts, kind of one in, one out, that we offer a greater than 99% uptime to all of our clients. And so in this facility, you kind of have a little different example. This is example of a client who is capturing their tank vapor as well as gas from the truck loading via VRU. So VRU is just a compressor that moves gas, and it kind of monitors the pressure level of the tank and the truck so that you don't generate a vacuum and crush them. But anyway, this gas that you can see is generally in an atmospheric storage vessel and or low pressure tanks that get exposed to air. During the day, it gets warm, the temperature rises, the tanks breathe, and air contaminates it. So that, like we kind of mentioned earlier, that oxygen is a contaminant to pipeline operators. It accelerates corrosion, and it kind of makes other downstream processes problematic. And it potentially moves them closer to a premature failure. And, I think we've all seen enough high-profile pipeline failures in our lifetime. The 0.2, like we stated earlier, is a catalytic system that it exceeds these expectations for pipelines really across any weather condition or any how strict a pipeline wants to be on oxygen with more than a 99% uptime.
Thanks, Marcus. So let's talk about another tool. We call this one the Sulfur Sentinel. There are a lot of application cases, and honestly, our EcoVapors clients tend to introduce new ones to us on a somewhat regular basis. But one of those applications is very similar to the 02, and that's where it's used to remove contaminants from the gas stream so that that gas can meet pipeline specification and be sold rather than vented or flared. Um, Specifically H2S. So by removing H2S or sweetening the gas by using a simple and effective tool in a manner that self-adapts to varying flow rates and varying H2S concentrations. It does this by using a dry media adsorbent that's contained in a proprietary vessel design that is customized for the application conditions. We look at H2S concentration, flow rate, operating pressure to come up with the way that we think is going to be the most predictable. It's got a low pain in the butt factor. There's no knobs. Again, it self-adapts and removes those contaminants from the stream so that they can be sold.
And similar to the 02, we kind of give you another list of regulations that we think are relevant. I won't repeat the ones that already kind of apply, but for sweetening units, which this would count as, this would be the same as Quad O rules, but sulfur, if you discharge sulfur, that's monitored under a different set of rules. What's probably the most impactful is that while, as Chad mentioned, most of these regulations allow flaring in extremely limited circumstances for 24 hours or less, because the goal is to reduce emissions. So think of it kind of like emergency only flaring. Something EcoVapor does offer is a mobile unit that could potentially allow an operator to run in stopgap mode. So Chad mentioned earlier where you have 5 days underneath the super emitter program to kind of begin, monitoring. This would allow you to kind of remain in compliance and not emit until you can find a more permanent solution and avoid shutting in. Because all the systems that we kind of design generally revolve around a 97 to 98% uptime approach. This kind of keeps the spirit of that 95% EPA capture rate at the forefront for any client, so they know that they can rely on the system.
Cool. The last product that we'll talk about, the last tool in the shed we'll discuss today, is the Tank Commander. And the simple why behind this is to get it all. The purpose here is to capture and sell all emissions on a facility, particularly one equipped with a vapor recovery tower upstream of that tank battery. Again, in other webinars, we've discussed at length how there's a discrepancy between volumes generated in the tanks between what's modeled in the software package and what's actually measured on site. That's not today's focus to get into those details, but at a high level, it's fair to say that there can be significantly more vapor generated in a tank battery than what a software package like Promax or HYSYS would suggest. So what is this? Well, this is a system that maintains tank battery pressure, both positive and also prevents vacuum conditions. It prevents vacuum conditions so that there's not an enormous inrush of air. Over 25% is where the 02 reactor tops out. We can process out a quarter of the stream as being air, but once it gets to be more than that, that can be a lot. So we prevent that. But also, by maintaining the other side of the pressure window for tank batteries, positive pressure, by eliminating that, there's no venting to worry about. You don't need to worry about detection, investigating super emitter events. If there's no gas to vent, then it won't vent. And the way that this does that is by bolting on to facilities with a vapor recovery tower. It harvests that tank vapor. It purifies out the oxygen contamination. All this is acting in concert under one control system. And then it sends that vapor to the existing VRU on location that's already pulling vapor off of the VRT in the first place.
And on this one, there's not necessarily any new regulations that this would, explicitly cover that weren't covered on the 02 product. But again, we offer a 97% uptime or greater on this product. In this scenario, you can kind of see exactly what Hans was talking about, where the client is trying to capture their flash gas off of the separators with a VRT, but they need some help with the remainder of the gas. And so the VMS system can still monitor the tank pressure and suck the tanks down appropriately, as well as if there's a truck loading event. And then, it feeds that gas along with the leftover gas from the VRT to the VRU. That gets kind of counted by the client, and then that gas can get sold. And then in this case, the flare is off or emergency only production.
And due to the simplicity of that system, it results in the highest reliability, lowest lease operating expense option to get it all and capture whatever the VRT leaves behind.
All right, let's move into Q&A. Thanks, Chad, Hans, Chris, and Marcus. We do have a couple questions that have come in, so I'm just gonna kind of throw them out there and see who wants to chime in and answer it. This one's pretty specific and it feels like a Chad, but I'll just throw it out there. I have an existing tank battery with only one well producing into it. If I drill a new well 1 mile to the east, connect it to the existing battery, is that entire battery now subject to Quad OB?
I would say yes, because you're routing new fluids to that existing battery. That would bring the battery into Quad OB when it comes to the storage tanks, potentially. You still have to look at the emissions, and then you'd still have to include LDAR as part of that. As part of your fugitive emission components, you'll have to do a investigation, whether it's the OGI camera or Method 21 along those lines. You'll need to look at that battery and the existing well as part of that. And then as far as the new well goes, it would be subject to Quad OB because it is a newly drilled well. But I believe the rules for that are that it just has to do the AVO inspections.
Okay, great. Thank you, Chad. Here's another one that maybe a Chad and or Chris. Can't we simply install a flare or an ECD and be in compliance with Quad OB?
Chris, do you
So
want to take that one? Or
Sure, I can start and feel free to chime in. So certainly you can use combustors and flares to meet a lot of the obligations in Quad O, B, and C. There are some sort of maintenance procedures that go along with that, right? So I mentioned earlier the legally and practically enforceable limit requirements for control devices on a storage vessel. Those can be kind of burdensome. You need to do an initial performance test. You need to establish parameters and do some parametric monitoring to show that you're meeting those parameters and achieving the control efficiency. Another piece of that is that, again, there's a relationship between Quad OB and the greenhouse gas reporting rules and the waste methane emissions charge. So under the revisions to subpart W for the reporting rules, EPA only lets you take credit for 98% control from a combustor if you're following the performance standards for refinery combustors. So it's pretty stringent. A lot of people may only be able to claim 95% reduction, even though your combustor is getting a higher control efficiency than that. That can impact you financially because you're reporting higher emissions to subpart W. That same data is used to calculate the waste emissions charge. And so you would be paying the $900, $1,200, $1,500 per ton of methane, even if you're not actually emitting it, just because you're not able to claim the higher control efficiency. So there are some downsides to using controlled or combustion control devices.
I think it's important to remember too that when it comes to installing that flare and getting a legally and practically enforceable limit, many states will give you a limit on VOCs such that you wouldn't be above the 6-ton threshold. But I'm not aware of any current state or previous permit that shows a limit on methane. So that might pull you into Quad OB.
Actually, that's a great point, Chad. And if I could add just one more thing. When when companies have done these flyovers of the basins and look for the large emissions events, one of the more common so-called super emitters is an unlit flare. And so there can be situations where your pilot light goes out, you're not aware of that, and you discover it after the fact. You may be out of compliance for one thing, but you may also have a very large emissions charge, because if you have to go back to the previous inspection date or previous maybe you had a flyover to show when your flare was working, you could, at least on paper, have a very long period of excess emissions and high charges, hundreds of thousands of dollars.
Wow, that's interesting. Another question, this one's also very specific. If we add a storage tank to a tank battery, does just the new tank need to be in compliance, or do all the tanks in the battery have to comply with Quad OB, even though they may not otherwise be covered?
So if you're just adding a new tank to an existing battery and you're increasing the capacity, you would be increasing the emissions. So it would most likely be subject to Quad OB. Now you still have to, you'll still have to do your evaluations and everything, but typically adding that tank would make you subject to it.
Let's see, this is kind of an interesting one. I think you may have touched on this, Chad, earlier. Chad, you mentioned super emitter events. Now, do I have to be worried about activists with OGI cameras trespassing on our well sites?
I mean, I think that's an ongoing concern for the industry overall, but if they're not one of the accepted or third-party, notifiers on the EPA's list, then they wouldn't be able to send that information to the EPA, and that information would not be acted upon. So no, it can't just be anybody. You have to go through that process and get approved.
Okay.
And if I could add to that, that concern about people trespassing in your sites actually led to a change between the proposed Quad OB and the final. And so OGI cameras are not eligible as a monitoring device that could be used to identify a super emitter. For one, you need to be able to quantify what the emissions rates are and show it's above that 100 kilogram threshold. But you can use mobile devices if they're mounted in a vehicle. You can use aircraft, but that was one of the reasons, was to prevent people from having an incentive to go trespass on your site.
That's interesting. Here's a permitting question. Does Quad OB or eventually Quad OC impact requirements for a Title V operating permit?
Yeah, I can start with that, and anyone else can jump in too if you want. I mean, certainly you have to comply with the new regulation. And so if you're writing an operating permit, and you have to submit your application 12 months after you commence operation, right? When you get to that point of submitting your Title V application, you would include the Quad OB regulations in your Title V permit. But if you're an existing Title V source, you do need to comply with Quad OB now that it is in effect. So even if it's not in your permit, they are applicable requirements and federally enforceable.
Here's another one that's fairly specific, and it sounds like someone's has a specific threshold in mind. So if my facility produces 19 tons per year of methane and 5 tons per year of VOC, am I in compliance with Quad OB?
So in compliance is a pretty broad term. And obviously Quad OB has a number of different affected facilities within it. I think this is probably talking about the storage vessels, where, as we mentioned before, the applicability threshold for Quad OB is 6 tons per year of VOCs and 20 tons per year of methane per battery. So if you're below that, then your storage vessels are not subject to the Quad OB requirements. But you would still have, for example, LDAR, you'd have other pieces of Quad OB that you need to live up to.
And it's also possible that your production could change. If it increases and you go above that threshold, then it would pull you into Quad OB. It's also possible that with those controls, if you want credit for those controls, if you want them to be legally and practically enforceable, then you'll need to be able to have a permit that shows that if you already have controls on the device or on the battery itself. If your emissions are uncontrolled, yeah, you'll just continue to track it. And if you do exceed the thresholds, then they could pull you in.
Okay. Looks like we have another specific question. If we recomplete a well, extend a lateral, or add a new well to a production pad, which increases production on the pad that was not covered by Quad OB, I think you just answered this, Chad. Is it now subject to Quad OB?
So can you repeat the early part? You said that it was was it a recompletion or just drilling a new well?
A recompletion, extending the lateral, or drilling the new well.
And drilling the new well would definitely pull you in as far as Quad OB goes. If you recomplete the well, if you're doing hydraulic fracturing or refracturing, then yes, that would pull you into Quad OB as well.
Yeah, and I think that is for both the storage vessels and the fugitive emissions inspections, whereas refracting a well is considered to be a modification.
Yep.
The part about extending a lateral is, I don't think that's specifically covered in Quad OB. It does talk about modification to a well or changing the operation that would affect your throughput. So I think the answer is going to be yes, although I would want to go back and double check the rule on extending the lateral, but I would see that as a modification of the well that spills over and causes a modification of your storage vessel and your LDAR inspection frequencies.
Okay.
And it could potentially affect the associated gas depending on its disposition.
Thank you. Hans, there's a question that's aimed at you. When it comes to defunct oil and gas wells before they are plugged, like here in the northeastern U.S., can EcoVapor's 0.2 oxygen removal system be used to capture VOCs, NOx, CO2, and methane with a barrel over the well and a pipeline to a special tank battery in order for the resource for repurposing? So I think what he's saying is, if I have a well that's no longer economically feasible, it's going to be plugged at some point in the future, can you use 0.2 to capture those pollutants with a barrel over the well?
Well, I guess there's two ways to answer that. One is, well, if you got a barrel over the well, it might try to go somewhere else, just as gas is wont to do. But I do think that ultimately, that's the purpose of what we're trying to accomplish here. And we'd have to look at the application specifics, flow rates, what the profile of flow rates look like throughout the day. Typically, as well as reach the end of their life, they can be put on artificial lift, plunger lifts. That's an application that EcoVapor's approached in the past successfully. But ultimately, what we're trying to do is capture as much emissions as we possibly can profitably by selling them. And if we get to that point where we don't think that it's going to be economically justifiable, then we'll say so. That doesn't mean that it's a dead end. We've seen EcoVapor equipment put on locations where all parties understand that the economics aren't going to pay out. This is really an exception to the rule, but there could be societal pressures. This could be across the street from an elementary school at one point. Public license to operate within the community. Best practices. We've seen that in the past, but we have tried to meet the vast variety of well sites, big and small, and also as each individual site changes over time, as production rates decline, with right-sized equipment, so that we can prevent those emissions, and again boost the economics by increasing the production of that well, effectively routing that gas to sale. So let's take a look at the application.
And of course, contact us with any questions. This information, this contact data is in your handout. So I just wanted to thank thank you to our panel. Thank you to our participants. That concludes today's webinar, and we hope you have a good rest of your day.